Hi everyone, in this video we're going to look at applying the standard normal distribution. And so remember I talked before about the bell curve, so here's a bell curve. But when we're talking about the standard normal distribution, the mean is 0 and the standard deviation is 1. So this is what we call a standardized normal distribution. So we can sketch in the mean and remember that that's 0, and then whatever problem we're doing from there relates to that. So here we're looking at the probability that z is between negative 1.2 and 0. And so z is our sort of standard normal distribution value, and if it's negative 1.2 that we're looking at, then that's going to be to the left, and we're going to be looking at the area between that and the mean. And that area represents a probability that we are interested in. So that's what we have this table here for on our right, and you can see that we've got z in the corner, and the values going down represent decimal values of z, and then across, so we're looking for 1.2, and then across we have the next decimal point, and so because we're looking for exactly 1.2, we're looking at the decimal point of 0, so 1.20, and that brings us to this value here, 0.3849, and so that's what represents that probability that we've shaded in on our graph here. And you'll notice that even though we've got negative 1.2, because it's symmetrical, we look it up in our table as positive 1.2. So that area in there is 0.3849. Okay, so that means that the probability that z is between negative 1.2 and 0 is 0.3849. Alright, let's look at our second problem here. And just a moment. Alright, so we're looking at the probability that z is greater than 1.2, so we put the mean in again, and we put in a value of 1.2, and we're looking for the area between those, above 1.2, because it says where z is greater than 1.2. And so for either side of our normal distribution, they have to add up to 1 under the whole curve, and so 0.5 to one side. And so the area between 0 and 1.2 is still going to be 0.3849, but we're going to have to subtract that off 0.5 in order to find the area that's above 1.2. So just reiterating that, the area under the whole curve is 1, and the area to 1/2 of the curve is 0.5. And so if we subtract the area between the mean and the value that we're looking at above, then that leaves us with what's left above that value, so 0.1151. Okay, well, we'll finish this video here, and in the next one we'll look at the next problems. But just remember that key fact that the area under the curve is 1, and the area on each half above the mean is 0.5. Thank you.